everybody. It is so nice to be here in Thailand. Thank you for having me. What I'd like to do today is tell you a bit about what we do at Made in Space and a bit about manufacturing in space. But my real goal is to help you understand how some of the things we've been doing in space could transform industries on Earth. Because the space industry tends to operate on technologies that are a little bit ahead of their time. It's in other places you'd find here on Earth. For me, it feels a little bit like I've been in a time machine. I've gone to the future. I've seen what digital manufacturing and 3D printing has in store. And I have some ideas on where I think it fits into industries here on Earth. And my real goal today is to share with you some of those ideas, so hopefully you have a takeaway for your own businesses. To start, I wanted to show you this picture. It's probably the most ambitious exponential manufacturing idea I've ever come across. This is a city in space. It's the inside of a very long cylinder, and it rotates on its long axis to create an artificial gravity. There's rivers and lakes and trees, and it was designed in the 1960s. It's something that in the 1960s was conceivable and possible with manufacturing technology that existed then, and we are surely on a path towards creating these cities in space. Later this week, I have the awesome privilege of going to the Samui Island, and imagine one day Thailand building an island in space that is exactly the best condition you would ever have on Samui Island, the best day of the best part of the year, all the time. That's something that is possible one day in these things. So this is what drives me. It's what gets me excited, because the only way you can do this is if you make it there in space. But the challenge that why we need to build these, but also I think the challenge of what all of us here are trying to address one way or another, is that today on this finite planet that we live on, we have these limits to growth. This is a chart that was created in the book Limits to Growth, that it basically charts out the path of our trajectory of where we are as a species and how we are using up resources, and there'll be a point where we start to decline in our resource usage, population will taper off, food production will taper off, and there's this limit to how much we can grow. And to me, this is an unacceptable option for our future. Jeff earlier today mentioned we're here today and tomorrow to talk about designing a preferred future, and to me, this is not it, and we should look beyond the boundaries of this planet and realize that we live in a sea of abundance. Everything that we call a limit is no longer a limit when we are utilizing space to our advantage. I'll come back to that in just a little bit. But to tell you a bit about Made in Space, our focus has been to develop manufacturing technology so that we can move beyond launching everything on a rocket. And what I believe is one of the reasons that we've been able to do what we do is it's in the power of asking different questions. I implore you all to think about this. How can you ask a different question in the work you do? For us, we looked at the space industry. The general question is, how do we make a better rocket? How do we make a bigger rocket, a smaller rocket, a reusable rocket? And we asked ourselves, well, what if we never needed rockets at all? What would that look like? It's a very different question. It allowed us to explore a new set of ideas. And what we realized is it's not necessarily that you wouldn't have rockets at all, but maybe in the future we could launch something different into space. Rather than launching a satellite, what if we launched robots that manufactured the satellite in space? What might that look like? This is an artist concept from the early days of our company about 9 years ago of this idea of robots that get launched into space with 3D printers, and they go on to construct huge satellites, things that are hundreds of meters across. You could never have fit into a rocket. This is a giant antenna pointed at Earth, providing broadband internet directly to a cell phone on the planet, something that you could only do if the antenna was that big, and you could only have that big of an antenna if you manufactured it in space. So that was our vision. We're pretty well on our way doing this. We're actually designing the first versions of these robots now at Made in Space. But to tell you a story of how we got started, we don't go straight towards this type of idea. We have to start small and make baby steps. So we focused a lot on how to design 3D printers that would work in space, because that's really the key tool to make all of this happen. So we put 3D printers on the International Space Station, and I'll tell you one of my favorite stories of using a 3D printer in the space station, if you don't mind. This is Butch Wilmore. In 2014, was the commander of the International Space Station. So he's in charge. He's flying the ship. And that happened to be when we launched a 3D printer to the space station. It was the first machine that would ever manufacture off of planet Earth anything. So it's for us, a very historical moment. And Butch was the astronaut who used the machine. And one day in our little mission control room at Made in Space, where we get to command and control the 3D printer, we heard Butch say over his headset, and we're listening through the NASA speakers. He mentioned that he was missing his ratcheting tool, his wrench. And we thought to ourselves, well, did we hear that correctly? Did he really say he lost a tool? So we went and asked NASA, is it true? Did Butch lose his tool? And they said, yeah, we have no idea what happened to his tool. And we were taken back. How does an astronaut lose a tool in space? Like, this seems like a very important thing not to misplace. So that's why I have this picture here for you, so you understand that the International Space Station is not what we see in the movies. It's a very cluttered environment. There's things everywhere. And everything's floating. It's zero gravity. So, maybe he was working over here with his tool. He gets hungry. He doesn't set it down on a table to go eat lunch. He lets go of it because it will float. And then, of course, it wasn't there when he came back. So it was missing. We convinced NASA to let us design and 3D print a tool. Because it's digital manufacturing, the entire thread of design all the way to the point of making the tool exists digitally, which allows us to iterate very quickly, as you've been hearing other speakers talk about today. So this is the actual tool. It's designed within hours by our engineers, printed several times and tested. And then about 4 to 5 days later, after going through the paperwork with NASA to approve this tool to go to space, we're in our mission control room doing something that's never been done before. Rather than putting that wrench onto a rocket and launching it to the space station, we're sending the file to space. We're, in a way, emailing this hardware to space. So this is a real picture I took when it was happening. That you can see images of the space station as we're sending it there. And what happens is, the image here, inside this big glass glove box, you'll see the metal 3D printer that's about the size of a microwave oven. And there's a Lenovo laptop off to the side. And there's a little command window open. That's us. We're on the ground. We've essentially remote desktoped into a laptop on the space station. We send the file to that computer. And then we command that computer to send the file to the 3D printer and start printing this tool. It takes about 2 hours to print the tool. So all in all, with maybe 30 seconds to send the file up to space, and then 2 hours to print. One thing that we found that was amazing with the astronauts, and why I love this story, is that to the astronauts like Butch and all the astronauts who have used the printer since, this is like a magic box. They don't really know what we're going to print. They're off doing other things, as astronauts do, and they just come over to open the door and take a part out. When it's ready, they close the door on an empty box, and then a few days later when they come back and open the door, there's something inside again. So the last time we heard from Butch, it was an empty box, and he said that he's missing a tool. And this is a picture taken the moment he's opening the door, 5 days after he told NASA that he lost something. And then inside of the box that he left empty is the tool, the thing that he was missing. So it's like a magic box. They never know what will be inside next. Since this story happened in 2014, we've manufactured over 200 objects in space this way. These are 200 things that did not go on a rocket, but are in space. And I'd like to say that the moral of the story is that 3D printing fixes supply chain problems. And as evidenced here, this is a rocket on a train going to the launch pad. Space has a supply chain problem. So everything we put into space has to fit into a rocket, and in some cases, a rocket has to fit onto railroad tracks. So that's in the engineering world, we call this a requirement stack-up. So this brings me to my first lesson I'll share with you, which is this idea of the magic box. My belief is that the magic box will exist in many places, but mostly behind the scenes. Scott did an excellent job explaining some of these places that 3D printing already exists, that we all interact with, but we would have never known. But the reason it's behind the scenes, I think, has a lot to do with the theory of disruption and how disruption works. This is Clayton Christensen's famous chart on disruption, where he showed that for a technology to truly be disruptive, it exists below this threshold of what the customer or the consumer demands. And what it has to do is move beyond that threshold to this, where that yellow star is. That's the point where all of a sudden the technology is good enough, right? It still might not even be as good as the incumbent technology. Now, the reason I think 3D printing exists behind the scenes is because the things that we as consumers buy are very complex. There's a lot of that threshold of good enough is pretty hard to hit with 3D printing. When we're buying things that are as complex as a cell phone or a laptop computer, there's multiple materials, electronics, there's glass surfaces. Even the way it feels is one of those good enoughs. A 3D printed part doesn't feel the way our cell phone material feels. But I would wager that there are many items inside of even the electronics we buy today that could be 3D printed. And maybe they are, and none of us as the consumer know any better that there's a 3D printed part inside of the computer or inside, the 1,000 3D printed parts inside of an Airbus A350 airplane, or the 10,000 3D printed parts inside of a Rolls-Royce Phantom. We don't know that those 3D printed parts are there, and we frankly don't even care. But I think the magic box exists behind the scenes. And the next thing is how do you scale that up? How do you get to the point where you can mass produce these parts? I'll just quickly show one of the things I found pretty interesting is this company that they put a conveyor belt on their 3D printer. And now the 3D printer prints parts, and the conveyor belt just keeps pushing parts off into a collection bin. And you could imagine a factory filled with these machines. So every single day, the factory could be reprogrammed in software to build something completely different and mass produce those parts. And the next day, the factory builds something completely different. I remember in 2012, this article on The Economist. It was talking about digital manufacturing, and it claimed that it was the third industrial revolution. And I was really confused because, to me, a single technology isn't what makes an industrial revolution. It's merely a tool that allows maybe industry to advance. And it really left me questioning, well, what does define the Industrial Revolution, and what do we mean by it? And I'll share with you right now what I believe is the answer. I think it's a bit contrary to what most people believe. But I truly believe that it's new processes that unlock new industries. New processes unlock new industries. What I mean by that is best illustrated in this story. This is an image from 17th century England. These are hardwood birch trees. It's a forest of birch trees cut down. And the reason why is England at the time was using the birch trees for energy, burning the wood for fuel and for energy. And it was very easy arithmetic to calculate how many more trees were left And England knew they had an energy shortage. They were running out of trees. And there wasn't really a good solution. However, they did know that in these deep, water-filled mines, there was coal. And if there's just a way to remove the water from the mine, England would have access to a much more abundant and better form of energy, this coal, than the wood. It was a new process that unlocked this capability. A gentleman named Abraham Darby invented a process called the coke oven. And if any of you know what a coke oven is, it allows for incredibly high temperature to be reached that turns coal into coke, and coke is used to make steel. Now, it was with this invention of the coke oven that England had access to abundant and very low-cost steel. The steel, of course, was used to make pumps, which moved the water out of the mines. Now, the access to coal was either used in industry for energy to burn or to back into the coke oven to make more steel. And it was this one new process that unlocked not just one industry, but what we now call the first industrial revolution, or the machine age. It was the ability to build huge, huge devices out of this low-cost and abundant steel. And that's where it's this story that helped me understand what we really should be calling as the Industrial Revolution. Today, we like to term it as there's the first and the second and the third industrial revolutions. I would argue that this is just a paradigm in automation. It's one piece of a much broader thing that we could just call the Industrial Revolution. What I mean by that is the first, around the time of Darby's invention of the coke oven, we had mechanical production, railroads, steam power. The ability to automate our production was better than it was before. And that goes on for about a century, all the way to 1870 when the second paradigm is created. We have mass production, electrical power, the assembly line. Automation is now increased tenfold. Another 100 years almost, and we're into the third paradigm, program production. The computer allows for automation to happen at levels we've never imagined before, and the way we make things is automated in ways we've never imagined before. And now today we're somewhere in this new paradigm where the machines are connected to each other by the cloud with machine learning and AI. The machines are able to do design and manufacturing without nearly any human involvement. I would say that we are very close to near perfect automation in the way we make things. And we've definitely seen this in what we've been doing for space manufacturing. I think it has profound impact on how we make things on Earth when automation is nearly perfect. One of my favorite examples was this company they run an online 3D print shop where you can upload your CAD file, they print it, and they ship it to your business or your house. And one day they bought a robotic arm, and they automated the whole process. So now when you order a 3D printed part from this company, it's completely automated. You upload your file, their software decides which printer is available, it queues the printer, it prints your part. When the part's finished, the robotic arm reaches in, takes the part out, puts it onto this conveyor belt, and it goes down here and it gets packaged and shipped to you. So this is the impact of near-perfect automation in the way we make things. But it doesn't just stop there. The next thing that I've seen is the ability to go seamlessly from physical to digital and then back to physical again. What we've been doing in the aerospace industry is designing satellites that can service and modify and repair other satellites in space. So the way that works is we take a satellite with a very advanced type of 3D printer and a very advanced type of 3D scanner. We go up to a satellite that doesn't work any longer, and the first thing that happens is 3D scan the satellite. 3D scan and digitally model the asset that is in space, send all of those bits back down to Earth, and now all of a sudden the engineers on Earth have a digital version of something that is 800 kilometers away from them orbiting the planet, and then modify that digital form and then send the fix to the robot in space and 3D print it. That's happening in space, and it's been going on for a while, the development of this technology. And I think that has a lot of implication here on Earth. I like to use an example from Formula One, which Scott illuminated on as well. The point is that when we can modify things in the digital world, we can do it at nearly zero cost. Whereas in the physical world, when we modify things, it's very expensive. So imagine you have a Formula race car team, and you really need to win the next race. The first thing you do is you 3D scan your car. That's free. There's free software with your cell phone that you can take pictures around your car and get a point cloud, and now you have a 3D model of your race car. Now that you have a 3D model of the race car, you take computational fluid dynamic software, CFD software. It used to run on server farms. It runs on the cloud now. It's also pretty much free for you to use CFD. And you put in the racetrack, and you put in all the elements of that race car. And the race is coming up next week, so you know the racetrack, and you give it to the CFD. It runs simulations, and every time it computes the flow over the car, it changes the geometry, and it makes the perfect version of that race car. And then it sends to the 3D printer a bunch of parts, and you 3D print those parts out, you put it on your race car, and then you win the race. So that's the power of seamlessly going from the digital to the physical and back to digital again, or physical to digital and back to physical again. Now, it doesn't even stop there, because the process of manufacturing is becoming automated, as I mentioned, but so is the process of design. And you'll hear more. You've heard some earlier today, and you'll hear more about this later. I think it's one of the most important points of what's happening in manufacturing right now is what's happening in design. This is an image of what we call the women of Apollo. How many of you have seen the movie Hidden Figures? It's a great movie. You should see it. It's about the story of sending humans, the men to the moon and bringing them back safely. The women that worked at NASA were the ones doing all the math, all the computation to actually send a man to the moon and bring him back safely. And the job title of these women was called computer. So this is funny, that people used to be computers. That was just a regular old job title. There was entire cubicle farms of computers, of people doing the math, the computation. And it's really silly to think this, because we know what happened. We invented these computers, and the human became the mentor to the machine. Now, today design is very much like I think computers used to be when it was a human doing it. Think of the most beautiful things that we've ever built. They're all designed by the capacity of what we as a human being can imagine in our brain, or maybe in a group of people's brains. But not only that, we have to take what's in our brain that we've imagined and translate it to a computer, into CAD. And how do we do that? Well, we have one hand on a keyboard, one hand on a mouse. We design. We're trying to take the thing we're imagining and put it into software. And then after it's in the computer, we then have to manufacture it, and now all of a sudden, the thing in the CAD is not exactly the thing that gets manufactured. Now, that's all changing, because we have software that's doing design for us. We have essentially an AI design partner. We call this generative design, evolutionary design. But essentially what it means is that we can tell the software what it is that we want and the environment around what it would exist in. And the software goes about designing. We don't give it a design and say, make this better. We give it a blank slate and say, design me something for this application. And in the time that a group of people or a design group could come up with one good design, the software comes up with thousands of designs with all of the data to back up which one's best. And when we allow an AI to design for us or with us, we get really interesting results. We get things like lattice structures designed right into the part, or topology optimization, so the lattice is stronger in one area and maybe more sparse in another area. We have trabecular structures, things like what makes a bone porous, so you can lightweight apart from the inside out. And then because everything's being designed in software, it's being simulated and analyzed in software, so we have real-time simulation. I'll give you an example of something that we've done with generative design. It's one of the most fascinating things I've seen designed this way. We decided to see what software would do if we gave it a really, really hard design problem, something for space. We decided to have it design something that's really big. We said, what would happen if software designed a solar farm in space, something that can generate 30 megawatts. This is like as big as the big solar farms you see on planet Earth. The image here is a design. The ideas of solar farms in space go back decades, and the designs always look like this, just big flat, panels, basically. So we gave the design factors to the software. That's what's right behind me. Things like the location in space, the surface area that would have solar panels on it. We told the software about how the manufacturing technology works and the materials it uses. And then we let it do the work. And I'd like to show you all a video of kind of the design process of what happened when we let the software design for us. Because what it came up with, we would have never been able to imagine. The software's imagining things that we can't imagine. It looks to me like if an alien spaceship showed up, and that's what we would see. So let me play the video. So first, we told the software a little bit about the structure, where it would be, how it orbits the Earth, and from that information, it starts designing a structure, and it starts to carve away material. These are the iterations that you're watching. It's lightweighting and lightweighting. It's in zero gravity, so it never has to support even its own weight. Then it takes all of that information and turns it into a set of trusses based on how the manufacturing technology works. This structure is 5 kilometers long, so it's huge. And then this is just a kind of an idea of how the solar panels get assembled to the outside. So it's this huge, three-dimensional spaceship, alien-looking spacecraft thing. We would have never conceived of that, but it's a really interesting solution to this problem. So when I saw this, I was really taken back by it, because it made me realize that maybe we're headed in a very similar direction with design that computers had. Maybe in a generation or two, everybody in an audience will laugh when they hear that people used to be engineers and that people used to be designers, because it'll just be commonplace that the software does that design. But that makes us as the engineer and the designer, it's like we have superpowers. Imagine when you all of a sudden have at your fingertips this software that can design better than the best team of designers could have ever designed. That's what we have coming very near in the future. So all kidding aside, what I'm trying to say is that if robots don't steal your job, software probably will. That's my joke. So in the little bit of time I have left, let me explain my idea on how can we take all this, synthesize it, and really think about creating impact and envisioning a new future for manufacturing, one that surely Thailand can be a huge player in. So recall I talked about these paradigms in automation. To me, there's other paradigms that make up our industrial revolution or our industry. One that I spend a lot of time thinking about is the paradigms of location. I think this is one that isn't talked about enough, is that there is a paradigm of where things are made. The world has become very accustomed to the point that a lot of things are made here in Thailand or in the neighboring countries and shipped around the entire planet. But this too is changing. Okay, this too is changing. Things are going to be made locally because of these new manufacturing technologies. When we can send a file all the way to the astronauts in space and make something for them, who's to say that you can't have a 3D printer in your neighborhood or your town and have a part shipped the same way to get to you much faster? So location is an interesting paradigm, but as long as we think of Earth as a location, we're trapped in this point that there is a dark side to industrialization. We have to extract resources from mountains, and we turn mountains into holes in the ground to get the resources for how we make all the things that we depend on. And one day we will run out of mountains to turn into holes in the ground. I can guarantee that. So I spend a lot of time thinking about space as a really interesting location, because space has things that we don't have here on Earth. We have zero gravity, but we also, in a centrifuge, can spin and create any gravity that we want. Imagine centrifugal casting of giant structures in space. We have a vacuum environment. We have more solar power from the sun than we would know what to do with. So space is this really interesting environment for manufacturing. And if I'm right in the idea that new processes unlock new industries, imagine what new processes we could invent and unlock when we go to space and start doing our manufacturing there. And this is something that's already underway. We've been developing optical fiber that is 10 times better than optical fiber made on Earth if it's manufactured in space, as one example. So I'll leave you with that. This is a picture of us from space. I think Thailand has an important and very huge role to play in the future of how we envision manufacturing. So thank you for your time.